My solution is here at -1, 0. Last one. Really quick. We have 0. Doesn't matter that it's on the left-hand side. And we have x squared plus 2x plus 4. So if I look at where my graph is, my parabola, and if I look at where x equals 0, where do they intersect? Nowhere. So if they don't intersect at all, what do you think we write? No solution. Perfect. There will come a point in time in the second half of this quarter, or of this like unit, because unit 5 is in 2 parts, where we will talk about something called imaginary solutions. But for now, we got no solution. Now, let's go in and let's do some factoring. We are trying to identify solutions. And so basically what we're doing with 4, 5, 6, and 7 is we're kind of doing this process, but we have to figure out where the factors are equal to 0. So let's go in. If I wanted to factor this, the first thing I have to do is move all of my numbers to one side. So I need to go in and I need to subtract 12. Bless you.
Christian.
Wyatt, close your computer. All the way. Thank you. So, what do I do first?
Find, multiply a and 2 and 12.
What do I do first? Greatest common factor. Thank you, Vanessa. There is a GCF. The GCF is what? 2. So I'm going to pull a 2 out of everything. X squared minus x minus 6 is equal to 0. Now, how do I factor my parentheses? Multiply a and c. So a times c is -6, and we want something that adds to -1. Multiplies to -6 and adds to -1.
-6 -3 and 2.
-3, +2. There we go.
Thank you.
-3 and +2. It multiplies to -6. It adds to -1. Now, in the factoring we've discussed before, if you have a equal to 1, it's not a problem where you have to go through and split the middle and group and get your answers. You can take those factors directly and you can turn them into x plus 2 and x minus 3. This only works when a is equal to 1. If a does not equal to 1, you have to go the long way. Now, the part that is new, because technically, other than setting it equal to 0, none of this is new from unit 4. We learned this before. In order to solve, you have to take every single factor and set it equal to 0. So technically, I'm going to take the 2, set it equal to 0. I'm going to take the x plus 2, set it equal to 0. I'm going to take the x minus 3, set it equal to 0. And this is where I'm going to get my solutions. So 2 of them should be pretty straightforward. We should get x equals 3, and we should get x equals -2. Because I just subtract 2 from both sides. I add 3 to both sides. The reason why I have you set 2 equal to 0 is sometimes there's an x there that you have to solve for. If you don't have a variable to solve for, you just leave it alone. So in this case, 2 equals 0, we're just going to ignore it because there's nothing there that I can get completely by itself. It's 2 equals 0. Nothing's going to happen. But if I had a 2x there, then I would have a third answer. But for now, we just have 2. That is it. Do I have any questions so far? Okay, let's try it again. For number 5, I'm going to do something similar. I'm going to move that 28x over. So 3x squared plus 28x plus 9 equals to 0. Now, do I have a greatest common factor?
3.
Can I divide 28 by 3?
No.
No. Okay, So in this case, I don't have a greatest common factor. So I'm going to go straight to A times C and B. So I need something that multiplies to 27 and adds to 28. 27 and 1. Right? If I multiply 1 and 27, I get positive 27. If I add them, I get positive 28. Now, this one I want you to pay close attention to because the A is currently 3, which means I cannot just come in and say x plus 1, x plus 27. That is not how this one is going to factor. This is one where we have to do a little bit of the extra work for. So if you did not remember how to do this, I would highly suggest you pay attention. We're going to go in. We're going to split 28x. So instead of being 28x, I'm going to use 1 and 27 to make it into two different terms. So I'm going to have 3x squared plus 1x plus 27x plus 9 equals to 0. So the only thing I changed was I wrote 28x as 1x plus 27x. That's the only difference I've made so far. And I have to do this because A is not equal to 1. Now I go in, and this is where we group. We group the first two together, we group the last two together. So I am going to group 3x squared and 1x and 27x and 9. So once you have your groupings, you're looking for the GCF of each group. So what is the GCF of my first group? 1x. So perfect. I'm going to take a 1x out, and then I'm going to have 3x plus 1. What is the GCF of my second group? 9. So I'm going to take out a 9, and I'm going to have 3x plus 1 is equal to 0. Now here is where a lot of you potentially make mistakes. If you take out a 1, or if you take out a number, you have to write it down. If you didn't have that 9 there, a lot of us get confused and think that there's nothing happening and the GCF is x. Make sure you're writing out all of your work, otherwise you will not understand what you are doing. So whenever we factor this, one of the factors is the parentheses because they should match. The other factor is going to be x plus 9, and that's coming from the GCFs that we pulled out. Or you can say 1x plus 9. It's the same exact thing. So I now have my factored form. Any questions about factoring so far? Okay. I'm going to take both of my parentheses, 3x plus 1, set it equal to 0, x plus 9, set it equal to 0. I know that this one is going to be x equals negative 9 because I just have to subtract 9 from both sides. The other one is a little bit trickier because it's kind of like 2 steps. I first subtract the 1, and then in order to get x completely by itself, I have to go in and divide by 3. So my answer is going to be negative 1/3. Yes, you have to take it all the way to a fraction. You don't have to convert it to a decimal. If it was something like 2/4, we would want you to simplify it to 1/2, but this would be a perfectly fine answer, negative 1/3. Okay, any questions so far? Sweet. Let's go in and let's try it again. Now, sometimes they ask you to solve, and it's not set equal to 0. The only additional step that you have to do is set the whole thing equal to 0. Doesn't make a big difference. If you have something on the other side, you need to move it to the right side, and then you need to set the whole thing equal to 0. Now, if I go in and I factor this, I have x squared plus 10x plus 25, which does not have a greatest common factor. So I'm going to go straight in, and I have a times c, and I have b. So what multiplies to 25 and adds to 10?
5 and 5.
5 and 5. So when I factor this, I'm going to have x plus 5, and I'm just going to put the 0 on the right-hand side. It does not make a huge difference. Equals to 0. So if I have the same factor twice, how many solutions do you think I have? 1. You don't have to set both of them equal to 0. If you wanted to, you could. But if it's the same exact factor, when we grade your tests, we're only looking for the one answer, x equals -5. Okay, number 7. This is, I'm going to go in and set the whole thing equal to 0. I have a GCF. What do we think it is? 2. Let's try 2. I think it's 2. I'm going to go in. I personally like to write out what my GCF is. It's not a requirement, but it does kind of help. 2x squared minus 11x plus 12 is equal to 0. And if you're not sure if you took out the biggest GCF, when you get to this parentheses part, you can always double check if there's still something in common. When I look at 2, 11, and 12, they've got nothing going on. So I know 2 was the right answer. So now I'm going to go in. I notice that A is currently equal to 2, so I cannot use the shortcut. I have to go the long way. So I'm going to multiply 2 times 12, and that's going to give me 24, and I have -11.
-8,
-8, -3. So -8 times -3 is positive 24, because a negative times a negative is a positive. And if I add -8 plus -3, I get -11. So that is what you're doing when you're going through this process to pick these numbers. You really, really have to know that 12 by 12 table really, really, really well. If you're unsure, and I'm going to talk to my people who are like, yeah, I get it, but I don't. If you think that you're struggling with identifying your numbers, you can always come in and you can kind of just make a chart of the things that multiply to make the number you're looking at. So like I can do 2 and 12, I can do 3 and 8, I can do 4 and 6. And then if you have them listed, sometimes it helps you to kind of pick which numbers actually work together. So like 24 and 1 wouldn't have worked. 12 and 8 wouldn't, or 12 and 2 wouldn't have worked, and 4 and 6 wouldn't. So if you're struggling and you cannot figure it out, start listing out things, and then hopefully one of them kind of pops into your brain that you may have not been thinking of. So now I'm going to go in. I'm going to kind of ignore the 2 at the front because sometimes that gets to be a little confusing. I'm going to rewrite this as 2x squared minus 8x minus 3x minus 3, or plus 12. Sorry, wrong number. Plus 12. There we go. The only thing that changes is the -11x got rewritten as -8x minus 3x. Nothing else from the quadratic equation is different. I'm going to go in. I'm going to group the first 2. I'm going to group the last 2. What is my GCF for the first group? 2x. So I'm going to have x minus 4. Now, usually, just another piece of advice for my people who are still struggling with this concept, if I know I've picked one GCF and I have this parentheses x minus 4, I know in the end I'm going to want this other parentheses to be x minus 4. So sometimes if you're getting stuck, it may help you to see that and realize like, oh, okay, if that has to be x minus 4, my GCF of the second group has to be -3. So it all, again, depends on that you pick the right numbers. But sometimes if you're not sure if it's a positive or a negative, knowing what that parentheses has to be in the end really, really helps you decide. So when I go to factor, I'm going to bring this 2 down with everything. 2x minus 4, 2x minus 3 is equal to 0. The only reason why I ignore the GCF 2 when I'm doing the factoring steps is because sometimes when I write it that way, people get confused with like, is that the GCF of the grouping? Is it the GCF of the whole problem? So I just leave it alone until the very, very end. Now, I'm going to go in and I'm going to solve. So I'm going to have 2 is equal to 0, x minus 4 is equal to 0, 2x minus 3 is equal to 0. This first one doesn't have anything to solve for. so I'm going to leave it alone. This should end up being x equals 4. Now, for the last one, remember, it's a two-step. The first thing I'm going to do is add the 3 to the other side, and then in order to get x completely by itself, I need to go in and divide both sides by 2. We do not require that you convert this to a decimal. You can leave it alone, bless you. You don't have to write it as 1.5. Now, if you do write it as 1.5, we will still give you credit for it. However, if you write the wrong decimal, we will mark it wrong. So that is why I say leave it alone. Don't even worry about converting it, because if you convert it incorrectly, it's technically the wrong answer. Okay. Any questions on solving by factoring? We know if we do not know how to factor, we need to be into tutoring like ASAP, because you have to know how to factor. I cannot stress it enough. It will not go away. If you think it's going to go away at the end of this test, it is not. So get into tutoring. Let's go on to solving quadratic systems. Now, the reason why we put both of these things on the same day is they're basically doing the same exact thing. So whenever you are solving a quadratic system, the first thing you should notice is you have two equations. Whenever we solve these, all that you are adding to the process is that you have to go in and eventually set each equation equal to each other. So one of those starting steps is you need to get them to be in the form of y equals, but the whole goal and the whole reason why we do that is so that we can set them equal to each other and find where they're both true. This is another one where we are looking for the intersection, which means our answers are x comma y points. So the additional step here, everything we did just now, all you had to find was x, because if they are a solution or a root or an x-intercept, it's on the x-axis. We know what y is. Y is 0. For systems, you don't know that y is 0. Y could be other things. It could intersect at different points, so we have to find the y point that kind of goes with it. But all of the factoring and stuff is exactly the same. So the first thing I'm going to do for number 8, we already have them solved for y. So I'm going to go in and I'm just going to set these two equations equal to each other. That's all I did. I took the first equation, I set it equal to the second. And then we have to move all of the terms to one side. So I'm going to subtract the 2x, I'm going to subtract 6, and I'm going to get 2x squared plus 2x minus 12 equals to 0. Because positive 4 minus 2 is still positive 2. Negative 6 minus 6 is negative 12. Now, I'm going to factor like normal. Do I have a GCF? 2. I'm going to pull the 2 out. 2x squared plus x minus 6. Looks very similar to something we've done today. If I go in and I want something that multiplies to negative 6 and adds to positive 1, what two numbers? 3 and negative 2. 3 and negative 2. So if I multiply those, I get negative 6. If I add them, I get positive 1. So I'm going to go in, and because a equals to 1, I can just say x minus 2, x plus 3 equals to 0. You can only use the shortcut when a equals 1. I will say this 50 million times. You can only use the shortcut when a equals 1. So if I set each factor equal to 0, so 2 equals 0 isn't going to give me anything. X equals 2 is one of them, and x equals negative 3 is the other. The tough thing and where people lose points on a question like this on their test is this is where they stop. They box 2, they box -3, and they say they are done. However, if it is a system problem, you are going all the way to x comma y. So I need to figure out what the y value is for each of these x's. So what you have to do is you're going to take one of the equations. It doesn't matter which one. Personally, if I were you, I'd probably pick the easier one, which in this case is the 2x plus 6. And I'm going to take each of my x values and I'm going to plug them into that equation. So I'm going to have y equals 2 times 2 plus 6. Y equals 2 times -3 plus 6. So in this case, 2 times 2 is 4. 4 plus 6 is, what is 4 plus 6? 10. Okay, and then I have 2 times -3, -6. What happens when I take -6 and I add it to +6? Cancels out. It becomes 0. Now, again, here's another thing. People stop. They box the y and they're like, wow, I'm done. You're still not done. You have to take it all the way to an x comma y. So my final answers are going to be 2 comma 10, because it's where they intersect, and -3 comma 0. So it would technically, for those, it's crossing the x-axis, so that all of the y values are 0. So that it would always be 0. Okay, any questions on systems so far? All right, let's try number 9. Can I set these equations equal to each other how they are written? No, I need to get y by itself. So let's go in, let's add the 2x squared, and let's subtract the 12x, and the 23 is already there. We're moving it. We want to get all of the terms on one side, and we want to get y by itself. Okay, now that I have y equals and y equals, I can take the two equations and I can set them equal to each other. X squared minus 6x plus 14 is equal to 2x squared minus 12x plus 23. Personally, and a piece of advice, if you can keep your x squared positive, that is what I would do. If your x squared is negative, the shortcut does not work. The x squared has to be a positive 1 in order for the shortcut to work. So I'm not going to move everything to the left. I'm actually going to move everything to the right. So I'm going to go in, I'm going to subtract x squared, I'm going to add 6x and subtract 14, subtract x squared, add 6x, subtract 14. And that's so that everything on the left-hand side is going to cancel out. So I'm going to have 0 equals x squared minus 6x, and then 23 minus 14, 6, 7. Is it 8? 6, 7, 8? I thought it was 9. It's 9, right? Plus 9. Oh, like 6 takes me to 20, and then 3. So 6 and 3 is 9. Okay, so factoring. I'm going to go in. I don't have a GCF. So what multiplies to 9 and adds to negative 6?
3. 3 and 3.
Positive 3 and positive 3?
Oh, no, that doesn't work.
Negative 3 and negative 3. So I'm going to get 0 equals x minus 3, x minus 3. So if you have the same factor, again, you only have to find one answer. So I'm going to go in and do x minus 3 equals 0, and I'm going to get x equals 3. So again, biggest mistake people make is that's where they stop. They say, that's it, that's my answer, I'm done, I'm moving on. And I can tell you, If you were to do that on a test question, you're probably going to lose at least 2 or 3 points because you didn't go all the way to the end. So not ideal. Now I'm going to take my, why are we talking while I'm talking? All the way across the room. Okay, so what am I going to do next, Christian?
You're gonna plug in the x for one of the equations at the top.
Which equation do you want to plug into, Christian?
The top one.
The top one. All right, we can plug into the top one. So I'm going to take this top equation, and everywhere I see x, I'm going to plug in positive 3. So I'm going to go in y equals 3 squared minus 6 times 3 plus 14. This is where your number sense is very, very important. You have to be able to do these simple additions and subtractions and multiplying and dividing. 3 squared is going to give me 9 minus 18 plus 14. If you feel like you cannot process those numbers in your brain, it is completely okay. Take it in parts. If I wanted to combine 9 minus 18, I know that's going to give me negative 9 plus 14. And what is negative 9 plus 14? 5. Okay, am I done?
No.
How do I write my final answer? X comma y, 3 comma 5. Will Mrs. Martinez take off points if you do not write your answer as x comma y? Yes. If you don't put parentheses around x comma y, I am taking off points. For real, 100%. It is a coordinate point, meaning it needs to be in parentheses. No, parentheses.
That makes sense.
I need to see the parentheses around x comma y. The last little bit we're going to cover today. Very, very easy. These are two systems. Now, the reason why this differs from what we did at the very beginning is the very beginning was solutions. So it was always the x-axis. This is two different lines. It is approached in exactly the same way. You are looking at where the two graphs intersect. So another thing, if you need to make yourself a note so you don't forget, answer is intersection x comma y. Really, the only thing you don't have to write as x comma y is when you're just solving by factoring regular. Like just a regular problem is equal to 0. Now, in this case, I have two places of intersection. I have one at negative 3 comma 0. And I have another one at 1 comma 8. It does not matter. I'm going to get the question. Does it matter what order I write them in? It does not matter what order you write them in, but it has to be x comma y. Yes, CK.
This is the very first question because I'm confused. How did you write it? Or did you just write it as two different pairs? Okay, never mind that.
Nala, close your computer. We're not done. Thank you. What do I say for number 11? No solution, where they do not intersect. You guys will have 55 minutes to do your practice. I will be checking everyone's practice at the end of this class.